Welcome, friend, and settle in for a journey unlike any other. We are about to travel back across an ocean of time to a world long since vanished, a world ruled by magnificent and terrifying giants. This is the story of the Age of Dinosaurs, an immense and dramatic chapter in the history of our planet, known to scientists as the Mesozoic era. This era was not a brief moment in time. It was a colossal epoch that spanned an almost unimaginable 180 million years. To put that into perspective, the entire history of modern humans is but a tiny fraction of the time these creatures reigned. From approximately 252 to 66 million years ago, dinosaurs rose from humble beginnings to become the undisputed, dominant life forms on Earth. Over these millions of years, they evolved and diversified into a breathtaking array of species, each one masterfully adapted to the incredibly diverse environments of their prehistoric world. This grand era of life, this age of dinosaurs, is itself a sweeping three-act play. Each act is a distinct geological period: the Triassic, the Jurassic, and finally, the Cretaceous. Each period possessed its own unique global climate, its own burgeoning ecosystems, and its own remarkable evolutionary milestones that push the story of life forward. Our journey begins in the opening act, the Triassic period. This was the dawn of the dinosaurs, a time of recovery and new beginnings that lasted from about 252 to 201 million years ago. But what was the world like when these creatures first appeared? It was a world recovering from a profound trauma. The Triassic period directly followed the Permian-Triassic extinction event, a cataclysm so devastating it is often called the Great Dying. This was, by far, the most severe extinction in our planet's entire history, an event that annihilated roughly 90% of all marine species and a staggering 70% of all life on land. This mass extinction acted as a great reset button for life on Earth, clearing the slate and creating a vast, empty stage for new kinds of life to emerge, and eventually to dominate. It was in this strange, recovering world that the very first dinosaurs made their appearance, evolving during the late Triassic from small, unassuming reptilian ancestors. The earliest pioneers of the dinosaur lineage, creatures like the fleet-footed Eoraptor and the formidable Herrerasaurus, were not yet the giants of legend. They were small, agile animals that primarily walked on two legs, likely making their living by scavenging the kills of larger predators, or by hunting small prey themselves. During this early chapter, the planet looked vastly different. Nearly all the continents we know today were fused together into a single, colossal landmass known as the supercontinent Pangaea. This geographic arrangement created immense, arid inland environments where temperatures could swing to wild extremes. These harsh, dry conditions were the crucible in which the evolution of the first dinosaurs was forged, shaping them into resilient survivors. They shared this world with other fascinating reptiles, such as the winged pterosaurs, who were just beginning to take to the skies, and the ancestors of modern crocodilians. It is important to remember that during the Triassic, dinosaurs were not yet the kings of their world. They coexisted with a variety of other creatures, including strange, mammal-like reptiles known as therapsids, who were, for a time, the more dominant group. Nevertheless, by the time the curtains closed on the Triassic period, the first major groups of dinosaurs, including the carnivorous theropods and the ancestors of the long-necked sauropodomorphs, had successfully established themselves and begun to diversify, setting the stage for the next, more spectacular act. The second act of our story is the Jurassic period, a name that likely conjures images of towering giants and dense jungles. Lasting from 201 to 145 million years ago, the Jurassic marked a time of profound global change. The great supercontinent of Pangaea began to fracture and drift apart, a slow but relentless process that created new coastlines and vast inland seas. This fragmentation dramatically altered the global climate, making it far more humid and stable. These changes nurtured the growth of lush, sprawling environments, which in turn supported an incredible explosion of dinosaur diversity. It was during the Jurassic that dinosaurs truly came into their own, establishing their dominance over the land and, through their evolving avian cousins, the air. What's truly astonishing is that many of the most iconic and beloved dinosaur species appeared during this period. Picture the massive, long-necked Brachiosaurus, a living skyscraper of flesh and bone, and the colossal Diplodocus with its whip-like tail. Imagine the fierce predator Allosaurus, a fearsome hunter that prowled the Jurassic plains. This era also witnessed the rise of the armored dinosaurs, such as the incredible Stegosaurus, with its distinctive double row of bony plates along its back and its lethally spiked tail. The landscape of the Jurassic was a sea of green, but a very different green than we know today. The vegetation was dominated by hardy plants like cycads, ferns, and towering conifers, which formed vast primitive forests. These ancient plants provided a near-endless buffet for the gigantic herbivorous dinosaurs, while the carnivorous species flourished at the top of the food chain as apex predators. The Jurassic was also a pivotal time for the evolution of flight. It was during this period that the first true birds, like the famous Archaeopteryx, emerged, showcasing a fascinating mix of both dinosaur and avian features. In the skies above, the flying reptiles called pterosaurs soared on leathery wings, while the oceans teemed with their own giants, massive marine reptiles like the long-necked plesiosaurs and the dolphin-like ichthyosaurs. The Jurassic was, in essence, a world teeming with vibrant, interconnected ecosystems, with dinosaurs adapting to fill every available niche. The third and final act in the Age of Dinosaurs was the Cretaceous period, which was the longest and most diverse chapter of the entire Mesozoic era, lasting from 145 to 66 million years ago. By this point in Earth's history, the dinosaurs had spread across the entire globe. The continuing breakup of Pangaea into smaller, more isolated continents created geographical barriers that drove evolution into high gear, leading to the emergence of unique and specialized dinosaur species in different parts of the world. It was during the Cretaceous that some of the most famous dinosaurs of all time walked the Earth, including the mighty Tyrannosaurus rex, the three-horned Triceratops, and the cunning Velociraptor. The herbivorous dinosaurs diversified dramatically. Great herds of duck-billed hadrosaurs and horned ceratopsians roamed the plains, while colossal predators like T-Rex ruled as the undisputed kings of the land. At the same time, smaller feathered theropods were becoming increasingly bird-like in their appearance and behavior. A revolutionary change also occurred in the plant kingdom during this time. The appearance of the first flowering plants, known as angiosperms. These newcomers began to replace the more ancient ferns and cycads as the dominant form of vegetation, creating entirely new ecosystems and influencing the diets and behaviors of the plant-eating dinosaurs. One of the most captivating aspects of the Cretaceous is the wealth of evidence we have for complex social behavior in dinosaurs. Fossilized nests, clutches of eggs, and beautifully preserved footprints reveal that many species were far from solitary brutes. They engaged in sophisticated parental care, undertook long migrations, and lived within complex group dynamics. For example, the fossils of a dinosaur called Maiasaura, whose name means good mother lizard, show that these dinosaurs carefully nurtured their young in nesting colonies, a behavior that brings them touchingly close to our own understanding of family. But, as with all great stories, this one had to have an end. The age of dinosaurs came to a sudden and catastrophic conclusion 66 million years ago with the Cretaceous Paleogene, or KPG, extinction event. This mass extinction, most likely caused by the impact of a massive asteroid near modern-day Mexico's Yucatan Peninsula, created the enormous Chicxulub crater. The impact unleashed unimaginable devastation, triggering global wildfires, colossal tsunamis, and a nuclear winter that plunged the world into darkness and cold, disrupting ecosystems everywhere. This single event wiped out approximately 75% of all species on the planet. It marked the final tragic end for all of the non-avian dinosaurs. Yet, life found a way. Some of the smaller feathered theropods managed to survive this global catastrophe, continuing their evolutionary journey to become the modern birds we see today. This extinction also cleared the world stage once more, paving the way for a new class of animals, the mammals, to rise from the shadows and eventually dominate the Earth. Although the great dinosaurs themselves are long gone, their legacy endures. Every fossil discovery offers us a precious window into their incredible world, revealing their diversity, their adaptations, and their behaviors, inspiring a sense of awe and curiosity that never fades. And in the birds that fly in our skies, we have living, breathing reminders of their dinosaur ancestors. A beautiful testament to the enduring and powerful impact of evolution. The age of dinosaurs remains one of the most fascinating and awe-inspiring chapters in the epic story of life on Earth. A powerful monument to the resilience and majesty of life itself. The story of the dinosaurs is, above all, a story of stunning success and unparalleled adaptation. Over the course of their astonishing 160 million-year reign on our planet, they evolved into an extraordinary, almost unbelievable variety of shapes, sizes, and lifestyles. From dinosaurs so small they resembled modern-day birds, to the colossal, long-necked giants that would have dwarfed any land animal alive today. Their ability to adapt to nearly every conceivable environment and ecological niche was simply unmatched. To truly appreciate this diversity, we must travel back to their very beginnings, to their evolutionary roots in the Triassic period. The first dinosaurs emerged approximately 230 million years ago, evolving from small reptilian ancestors. These early pioneers were part of a much larger and more ancient group of reptiles, known as the archosaurs, a ruling reptile clan that also included the ancestors of modern crocodilians and the winged pterosaurs. Picture the world at that time. It was a planet recovering from the most catastrophic event in its history, the Permian-Triassic extinction. In the wake of this devastation, which wiped out most life on Earth, countless ecological niches were left vacant. It was into this vast open world that the resilient archosaurs thrived, giving rise to a host of new species that could exploit these empty roles. And from this hardy stock, a new kind of creature was about to emerge. The earliest known dinosaurs, animals like the fleet-footed Eoraptor and the formidable Herrerasaurus, were small, bipedal predators. They were agile and quick, likely hunting small prey to survive. But what was their evolutionary secret? What gave them the edge that would eventually lead to their global domination? Their success stemmed from a crucial anatomical innovation: their upright posture. Unlike sprawling reptiles such as lizards, whose legs jut out to the side. Dinosaurs had their legs positioned directly beneath their bodies. This seemingly simple change was revolutionary. It allowed for far more efficient movement and greater endurance, setting them apart and laying the foundation for their future success. Now, what's truly fascinating is that this entire vast kingdom of dinosaurs, with all its incredible variety, can be neatly divided into two great branches, two major families. And this fundamental split, which defines every dinosaur we know, all comes down to the structure of their hips. These two groups are known as the Saurischia and the Ornithischia. First, let's meet the Saurischians, whose name means lizard-hipped dinosaurs. This enormous group is a tale of two extremes. It included both the fearsome carnivorous dinosaurs, known as theropods, and the colossal long-necked herbivores, the sauropodomorphs. The theropods were the celebrity carnivores of the prehistoric world, the bipedal predators that have captured our imaginations for centuries. This group includes some of the most famous names of all: the mighty Tyrannosaurus rex, the cunning Velociraptor, and the powerful Allosaurus. They were primarily hunters, defined by their sharp, serrated teeth, powerful jaws, and, as we've more recently discovered, in many cases, feathers. In fact, it is from this very group of dinosaurs that modern birds eventually evolved, making them their direct ancestors. The other side of the Saurischian family included the sauropodomorphs, the living mountains of the Mesozoic. This group included true giants like Brachiosaurus, Diplodocus, and the absolutely immense Argentinosaurus. These were massive herbivores, characterized by their incredibly long necks and equally long tails. They were adapted to a life of browse on vegetation high up in the treetops, using their sheer, breathtaking size as their primary defense against any predator foolish enough to challenge them. The second great branch of the dinosaur family is the Ornithischia, the bird-hipped dinosaurs. An interesting fact is that despite their name, this group is not the one that led to birds. These dinosaurs were almost all herbivores, and they evolved a stunning array of specialized adaptations for defense and social interaction. Think of this group as nature's gallery of defensive innovation. It included the ceratopsians, like the famous Triceratops, which brandished large bony frills and sharp horns, likely used for protection from predators and for display to rivals or mates. It also included the stegosaurs, such as Stegosaurus itself, instantly recognizable by the double row of large plates down its back and a lethally spiked tail used as a formidable defensive weapon. Then there were the hadrosaurs, often called the duck-billed dinosaurs, like Edmontosaurus. They developed incredibly sophisticated teeth, forming dental batteries perfect for grinding down tough plant material, and many had hollow crests on their heads that they may have used to produce loud vocalizations. Finally, rounding out this group were the ankylosaurs, such as Ankylosaurus. These dinosaurs were the living tanks of their time, heavily armored dinosaurs covered in bony plates and wielding powerful clubbed tails that made them nearly invincible to attack. Of course. Let's continue our story. We've explored the vast timeline of the dinosaurs and the two great branches of their family tree. But now, we arrive at one of the most remarkable and breathtaking discoveries in the entire history of science. A revelation so profound that it has fundamentally reshaped our entire understanding of what dinosaurs were, transforming our image of them from slow, scaly reptiles into something far more dynamic, vibrant, and familiar. What if I told you that the dinosaurs never truly vanished from the face of the earth? What if they are still with us right now, living and breathing in our modern world? This might sound like a fantasy, but it is one of the most astonishing truths in all of evolutionary science. One of the most remarkable realizations in modern paleontology is that the birds we see every day, from the sparrows in our gardens to the hawks soaring in the sky, are the direct descendants of theropod dinosaurs. This intimate, evolutionary connection has completely revolutionized how we view these ancient creatures, transforming them from our old image of cold-blooded, lumbering monsters into dynamic, energetic, and feathered animals. By studying the fossil record and comparing it with modern birds, scientists have uncovered the fascinating and intricate details of this incredible transition, revealing the story of how ancient dinosaurs took to the air. So, where does this incredible connection lie? The link between dinosaurs and birds is found within that theropod group we spoke of earlier, the diverse lineage of bipedal, primarily carnivorous dinosaurs that included titans like Tyrannosaurus rex and agile hunters like Velociraptor. Scientists have found that these theropods share a host of skeletal characteristics, with modern birds, clues etched in bone that tell a story of a shared ancestry. For instance, many theropod dinosaurs had hollow bones, a feature that made their skeletons both incredibly lightweight and remarkably strong. This was a perfect adaptation for an active lifestyle and would later prove essential for enabling flight in their avian descendants. Both theropods and birds also share a similar foot structure, with 3 primary toes pointing forward and a smaller, backward-facing 4th toe. And perhaps most famously, they share the furcula, better known as the wishbone. This fused clavicle, once thought to be unique to birds, is present in many theropods and plays a crucial role in the mechanics of the flight stroke. For many years, these skeletal similarities were the main evidence. But then came a wave of breathtaking fossil discoveries, particularly from sites in China's Liaoning province, that revealed something astounding. Many of these theropods were covered in feathers. Species like Microraptor, Anchisoropus and Caudipteryx were found preserved in stone with clear impressions of feathers or feather-like structures. This was a game changer. It proved that feathers were not unique to birds. But here is the fascinating part. These early feathers were likely used for other purposes long before they were ever used for flight. They probably evolved initially to provide insulation, helping smaller dinosaurs regulate their body temperature, or for dazzling visual displays to attract mates or intimidate rivals. In this grand evolutionary story, one creature stands out as a true star, a perfect bridge between 2 worlds: Archaeopteryx. Often called the first bird, the discovery of Archaeopteryx was a groundbreaking moment in our understanding of the dinosaur-bird connection. This incredible animal lived about 150 million years ago during the late Jurassic period, and its fossils, first discovered in Germany, show a perfect mix of dinosaur and bird traits. On one hand, it had very dinosaur-like features, including a jaw full of sharp teeth, a long bony tail, and clawed hands. But on the other hand, it possessed distinctly bird-like traits, including fully formed flight feathers, a wishbone, and an opposable hallux. A backward-facing toe perfect for perching on branches. While Archaeopteryx had feathers clearly adapted for flight, it likely wasn't a powerful flyer like modern birds. It probably could only glide for short distances, or perform brief bursts of powered flight, perhaps similar to a modern pheasant. Archaeopteryx serves as the quintessential transitional fossil, beautifully bridging the evolutionary gap between non-avian dinosaurs and modern birds. The evolution of feathers themselves played a central role in this grand transition from land to air. As we've learned, these structures likely began as simple filaments for retaining body heat, which suggests that some dinosaurs were indeed warm-blooded. This would have been especially important for smaller theropods living in cooler climates. From there, feathers could have become more complex and brightly colored, used for courtship displays, much like a modern peacock uses its spectacular tail. Over millions of years, as these feathers became more specialized and aerodynamic, they began to provide an advantage for movement, allowing species like the four-winged Microraptor to glide between trees. This gliding phase was a critical stepping stone that eventually led to true powered flight in the earliest birds. Of course, taking to the sky required more than just feathers. It demanded significant changes to the entire theropod body plan. The long, bony tails of their ancestors were gradually replaced by a fused structure at the base of the spine called a pygostyle, which supports the tail feathers in modern birds and allows for better maneuverability in the air. Their forelimbs evolved into wings, with the fingers becoming elongated and some bones fusing together to create a strong, flight-ready structure. Birds also developed a keeled sternum, a large, deep breastbone that serves as a powerful anchor for the flight muscles, a feature absent in most of their non-avian dinosaur relatives. They also inherited a highly efficient respiratory system from their theropod ancestors, with a series of air sacs that allow for a continuous, one-way flow of oxygen, which is crucial for meeting the incredibly high energy demands of flight. So, the next time you look out your window, remember that modern birds are not just related to dinosaurs. They are dinosaurs, a living, breathing branch of the dinosaur family tree. With over 10,000 species found all over the globe, birds are one of the most diverse and successful groups of vertebrates on Earth. Their ability to fly has allowed them to colonize nearly every environment imaginable, and many of their behaviors, such as building nests, brooding their eggs, and communicating with complex vocalizations, can be traced directly back to their dinosaur ancestors. Their incredible range in size, from the minuscule bee hummingbird to the massive ostrich, reflects the same incredible adaptability that defined their ancient lineage. The feathers they wear are a direct inheritance, still used for insulation, waterproofing, camouflage, communication, and of course, the miracle of flight. In this way, the connection between dinosaurs and modern birds is one of the most compelling stories in science, a living bridge that connects the prehistoric past with our present world. Of course, we have unveiled the revolutionary connection between dinosaurs and birds, a link that reshapes our entire perception of these ancient animals. Now, let us zoom out from that single, fascinating branch of the family tree to appreciate the sheer, breathtaking diversity of the entire dinosaur kingdom. It was a world populated not by a few types of giants, but by a vibrant, living tapestry of creatures of every imaginable shape, size, and function. Dinosaurs were, without question, among the most successful and wonderfully diverse groups of animals to have ever walked the Earth. Over their immense 160 million year reign, they evolved into an extraordinary variety of forms, adapting to countless lifestyles and environments with a proficiency that is almost difficult to comprehend. Their ability to fill different ecological niches was simply unparalleled. Understanding this incredible diversity is key to understanding their long-lasting success. So, let's explore the dazzling array of forms these creatures took, from the impossibly small to the unimaginably gigantic. First, let's consider the incredible spectrum of their size. It's a common misconception that all dinosaurs were colossal giants. While the titans of their world are certainly the most famous, many dinosaurs were actually smaller than an average human. Can you picture a dinosaur no bigger than a modern-day chicken? This was a creature called Compsognathus, a tiny animal that likely darted through the underbrush of Jurassic forests, a stark contrast to the giants of popular imagination. But from these humble beginnings, the dinosaur family tree grew to produce the absolute largest land animals our world has ever known. We are talking about true titans like Argentinosaurus, a creature so massive that paleontologists estimate it may have weighed over 100 tons, a weight that would exceed an entire herd of modern elephants. This staggering range in size, from the tiny to the titanic, perfectly reflects their remarkable ability to adapt and fit into almost any available ecological role. This diversity wasn't just in size, but also in lifestyle. Not all predators were lumbering giants. Imagine agile, intelligent hunters like Troodon. While still a formidable predator, Troodon was much smaller, relying on its sharp claws, keen eyesight, and possibly a higher level of intelligence to hunt small prey and scavenge what it could. And what about the massive herbivores? How did they survive and thrive? Dinosaurs like the famous Brachiosaurus and the long, elegant Diplodocus evolved their massive bodies and incredibly long necks for a very practical reason: to reach food that no one else could touch. Their long necks allowed them to browse on vegetation high up in the treetops, giving them access to a plentiful food source while allowing them to cover a wide feeding range without having to frequently move their immense bodies. But in a world filled with such efficient predators, how did the plant eaters defend themselves? They evolved some of the most spectacular and effective defensive adaptations ever seen in the animal kingdom. Let's picture the living fortresses. Dinosaurs like Ankylosaurus. These creatures were covered head to tail in a thick suit of natural armor made of bony plates, and they wielded a heavy, powerful club at the end of their tails, a devastating weapon capable of breaking the bones of any attacker. Or consider the magnificent Stegosaurus, instantly recognizable for the double row of large bony plates along its back and a tail armed with long, deadly spikes. It's fascinating to think that these incredible features weren't just for fighting. They also likely played a crucial role in their social lives, perhaps used for complex courtship rituals or for intimidating rivals in territorial displays. Yet these were not just solitary creatures, wandering the ancient world alone. The fossil record provides us with tantalizing clues that many dinosaurs lived rich and complex social lives. Evidence suggests that many species lived and moved together in herds or packs. Perhaps the most touching evidence of this comes from the fossils of a dinosaur called Maiasaura, whose name means good mother lizard. Fossilized nesting grounds of Maiasaura indicate that these dinosaurs cared for their young long after they hatched, suggesting a level of parental care and complex social behavior once thought to be unique to mammals and birds. And where did this incredible diversity of life flourish? The answer is everywhere. The dinosaurs' success in adaptation was so profound that their fossils have been discovered on every single continent on the planet today, including the frozen plains of Antarctica. This shows us that they were capable of adapting to an astonishingly wide variety of environments, from lush, dense polar forests to vast and punishingly arid deserts. Key fossil discoveries, from the famous Hell Creek Formation in the United States to the incredible finds in the Gobi Desert of Mongolia, have revealed a treasure trove of new species and provided invaluable insights into how these dinosaurs lived, hunted, and interacted with their dynamic environments. Each fossil is a piece of a grand puzzle, and as we put them together, they continue to expand our understanding of the dinosaurs' incredible diversity and their epic evolutionary story. Their evolutionary success can be attributed directly to this amazing ability to adapt to a constantly changing world, a trait that allowed them to dominate the planet for millions upon millions of years. Dinosaurs were some of the most anatomically diverse and wonderfully adapted creatures to have ever existed. Their incredible evolutionary innovations allowed them to dominate the Earth for over 160 million years, thriving in a vast range of environments, from dense, lush forests to arid deserts and even the cold of the polar regions. From their powerful skeletal structures to specialized traits like horns, feathers, and tails, every dinosaur was a masterpiece of natural engineering, finely tuned to survive, hunt, and reproduce in their dynamic world. To understand their success, we must first look at their very foundation, their unique skeletal structure. What was the first secret that set dinosaurs apart from all the other reptiles of their time? It was their unique, upright posture. Unlike a modern lizard, which sprawls with its legs jutting out to the side, a dinosaur's legs were positioned directly beneath its body, much like a mammal's. Can you guess why this was such a revolutionary game changer? This posture allowed for far more efficient and powerful movement, and it provided much better support for large body sizes. This single anatomical shift was the foundation upon which their colossal sizes and active lifestyles were built. Now, let's take a tour of their anatomy, starting with the skull, the control center, and the business end of any dinosaur. A dinosaur's skull and teeth tell us a detailed story about what it ate and how it lived. The herbivores, the plant eaters, often had flat or grinding teeth perfectly designed for chewing tough plants. Consider the incredible dental hardware of the duck-billed hadrosaurs. They possessed hundreds of teeth tightly packed together to form a continuous rough surface, like a living wood chipper, ideal for grinding down difficult vegetation. In stark contrast, the carnivorous dinosaurs had mouths full of sharp, serrated teeth, like living steak knives, designed for tearing flesh. The mighty Tyrannosaurus rex possessed some of the largest and most powerful teeth of any known dinosaur, capable of crushing solid bone with a single, devastating bite. But their skulls weren't just for eating. Many dinosaurs had complex and often beautiful skull structures, adorned with crests, horns, or large frills, which were likely used for many purposes, including defense, communication with their own kind, or for dazzling mating displays. From the skull, let's move to the machinery of their movement, their limbs, and their style of locomotion. Dinosaurs evolved a whole variety of limb structures depending on the role they played in their ecosystem. The theropod predators, like the fearsome velociraptor, were bipedal, with strong hind limbs built for incredible speed and agility. The giant sauropods, such as Brachiosaurus, had 4 massive column-like legs, like the pillars of an ancient temple, which were necessary to support their immense weight as they moved. Their long tails, in turn, acted as a crucial counterbalance for their equally long necks. And some dinosaurs, like the clever iguanodon, were incredibly versatile, able to switch between walking on 2 legs or dropping down to all 4s, adapting their movement for different needs, whether they were feeding or running. And what powered these active bodies? Many theropod dinosaurs had a remarkably efficient bird-like respiratory system, with a series of air sacs that allowed for a continuous, one-way flow of oxygen through their lungs. This highly advanced breathing adaptation likely supported their energetic lifestyles and high metabolic needs. In a world filled with constant threats from predators, it's no surprise that dinosaurs evolved an extraordinary arsenal of defensive adaptations. How do you protect yourself when a creature like T-Rex is on the hunt? Some dinosaurs became living fortresses. The incredible ankylosaurs were covered from head to tail in bony plates called osteoderms, which formed a nearly impenetrable suit of natural armor. As if that weren't enough, they wielded a heavy, solid club at the end of their tails. A weapon that could deliver bone-shattering blows to any predator foolish enough to get too close. The majestic stegosaurs had their own unique defenses. Large bony plates arranged along their backs, which may have served both as a defense mechanism and a way to regulate their body temperature, and a tail armed with long, deadly spikes known as a thagomizer, a formidable weapon against any threat. Other dinosaurs, like the ceratopsians, such as Triceratops, used their heads as their primary defense, brandishing large, sharp horns and massive, bony frills that served multiple purposes, including protecting their vulnerable necks, intimidating rivals, and being used in courtship displays. And for those without armor, many relied on pure speed and agility to evade predators, like the ostrich-like ornithomimids, whose lightweight, long-legged builds allowed them to run at incredibly high speeds. Finally, let's look closer at the specialized tools they evolved for feeding. The gentle giants, the sauropods, like Diplodocus, had simple, peg-like teeth that were designed not for chewing, but for efficiently stripping leaves from the branches of tall trees. We've already mentioned the incredible dental batteries of the hadrosaurs, perfect for chewing tough plants. The carnivores were just as specialized. T-Rex had its bone-crushing jaws and teeth, perfectly designed for its role as an apex predator. Smaller predators like Deinonychus had terrifyingly sharp, curved claws on their hind legs, which they likely used to grapple with and dispatch their prey. And some dinosaurs, it seems, weren't picky eaters. Creatures like the ornithomimids may have been omnivorous, with toothless beaks and flexible diets that allowed them to eat both plants and small animals, adapting to whatever food sources were available in their environment. From their very bones to the tips of their claws, dinosaurs were the ultimate survival machines, each species uniquely equipped to thrive in the dynamic and dangerous world of the Mesozoic era. The Mesozoic era, so often called the Age of Dinosaurs, was a time of extraordinary ecological diversity. The dinosaurs lived in a world that would be almost unrecognizable to us today. A world sculpted by unique climates, shifting landmasses, and evolving ecosystems. They were masters of adaptation, finding ways to thrive in a vast range of habitats, from the most lush tropical forests to the driest deserts, and even in the cold and darkness of the polar regions. Understanding these ancient environments provides us with a precious window into the daily lives of the dinosaurs and the world they inhabited. To begin, we must picture the Earth itself as a planet in constant, slow-motion flux. During the Mesozoic era, the arrangement of the continents was in a state of continuous transformation due to the powerful forces of plate tectonics. This colossal continental drift was the master architect of the geography, climate, and the very ecosystems in which dinosaurs lived and evolved. At the very beginning of this era, most of the Earth's land was fused together into a single immense supercontinent known as Pangaea. Imagine what this would mean. A single vast landmass that created enormous arid interiors with wild, extreme temperature fluctuations and very limited rainfall. This uniform geography, without wide oceans to separate them, allowed the earliest dinosaurs, like the agile Coelophysis, to spread far and wide across the globe. But the Earth is a restless planet. By the time the Jurassic period dawned, the great supercontinent of Pangaea had begun to crack and fracture, slowly splitting into two new, major landmasses, Laurasia in the north and Gondwana in the south. This breakup was a world-changing event. It created thousands of miles of new coastlines, formed vast inland seas and led to more varied and humid climates across the globe. As the continents continued to drift apart during the final act, the Cretaceous period, they moved ever closer to their modern positions. What do you think happens when animal populations become separated by impassable oceans for millions of years? This geographic isolation became a powerful engine of evolution, driving the development of wonderfully unique and specialized dinosaur species on each of the newly formed continents. The climate of the Mesozoic era was also vastly different. For the most part, it was a greenhouse world, generally much warmer than today, with no permanent polar ice caps. This global warmth supported lush, abundant vegetation and allowed dinosaurs to thrive in high-latitude regions that would be completely uninhabitable for such creatures today. But this climate was not static. During the early Triassic period, the world was a hot and dry place, with vast deserts covering much of the Pangaean interior. Early dinosaurs like Herrerasaurus had to adapt to these harsh conditions, evolving lightweight bodies and efficient respiratory systems to survive. Later, as Pangaea broke apart in the Jurassic period, the climate became much more humid, leading to a great expansion of forests and wetlands across the world. These landscapes were dominated by towering coniferous trees, cycads, and ferns, providing a near-endless supply of food for giant herbivores like Brachiosaurus and Stegosaurus. The final chapter, the Cretaceous, was a period of dramatic climatic extremes, a world that featured everything from lush tropical regions to temperate forests and even chilly polar environments where snow would fall. It was also during this time that a revolutionary new type of plant appeared, the flowering plants, or angiosperms. These new plants began to change ecosystems all over the world, introducing new food sources and influencing the diets of herbivorous dinosaurs, like the hadrosaurs and ceratopsians. So, let's take a walk through some of these ancient habitats. Picture the Mesozoic forests, vast woodlands that ranged from steamy tropical rainforests to cooler temperate forests. The canopies were formed by tall conifers and cycads, and in their shade, giants like Diplodocus and Iguanodon fed on the high vegetation, while small hunters like Compsognathus darted through the underbrush below. Now, step into the harsh deserts and arid plains, home to hardy dinosaurs like Coelophysis and Plateosaurus, creatures that were built to withstand extreme heat and limited water. Then, imagine the low-lying wetlands and swamps, ecosystems teeming with life, providing abundant food and water that attracted massive herbivores like the hadrosaurs. These swamps were also the hunting grounds of terrifying predators like Spinosaurus, a unique dinosaur that evidence suggests was semi-aquatic, hunting fish in the ancient rivers and lakes. And can you believe it? Dinosaurs even conquered the poles. Fossils of creatures like Cryolophosaurus and Leiolinosaura have been discovered in what were once polar regions. These remarkable animals adapted to survive long, dark winters and cooler climates, with some species perhaps even having insulating feathers to keep them warm. But these creatures did not live in isolation. They were part of incredibly complex ecosystems, an intricate web of life that included a vast variety of other plants and animals. Their interactions shaped their evolutionary success. There were the constant, dramatic predator-prey dynamics between carnivores like T-Rex and the herbivores they hunted, a story told to us today through fossilized bite marks. There were the great migratory herds of hadrosaurs that likely played a major role in shaping the vegetation of the landscape. And while dinosaurs ruled the land, the skies were dominated by the winged pterosaurs and the seas by massive marine reptiles like the plesiosaurs. We know these details thanks to the stories etched in stone, the fossilized nests in the Gobi Desert that show us where dinosaurs like Protoceratops nested in sandy dunes, and the fossilized trackways that reveal how great herds moved together, often following seasonal migrations. The world of the dinosaurs was just as dynamic, diverse, and wondrous as the creatures themselves. Dinosaurs were far more than just fascinating for their incredible size and diversity. They also displayed complex behaviors and intricate social structures that have captivated scientists and the public alike. The precious fossil evidence, including ancient trackways, nesting sites, and vast bone beds, offers us tantalizing glimpses into how these ancient creatures interacted with one another, how they hunted, how they raised their young, and how they survived in their prehistoric world. Understanding their behavior and social structures helps us breathe life back into these long-extinct animals, transforming them from static skeletons into living, breathing beings. One of the clearest pictures we have from the fossil record is of the great herds. Why would so many herbivorous dinosaurs choose to live together? The answer is a timeless one: for protection from predators and for greater success in finding food and raising young. The fossilized footprints they left behind, known as trackways, tell a vivid story of their group behavior. Imagine seeing rows of parallel tracks, all belonging to a dinosaur like Iguanodon, all moving in the same direction. This is direct evidence of coordinated herd behavior, a community on the move. Some of these trackways reveal even more touching details, showing mixed-age groups traveling together, with the smaller tracks of young dinosaurs found safely in the center of the group, shielded by the larger adults on the outside. Further evidence comes from what are known as bone beds, sites containing the remains of many individuals of the same species who died together. A massive bone bed of Centrosaurus found in Canada suggests that these horned dinosaurs lived in enormous herds, potentially numbering in the thousands. It's believed these mass death sites may have resulted from natural disasters, like a sudden flood that trapped an entire migrating herd. This also points to another complex behavior: migration. It's likely that some dinosaurs, like the duck-billed hadrosaurs, undertook vast seasonal migrations to find food or suitable nesting grounds, with trackways in places like Alaska, suggesting these herds moved over incredibly long distances. But perhaps the most compelling evidence of their social lives comes from their nests. We have discovered that dinosaurs exhibited varying degrees of parental care, with some species tenderly nurturing their young long after they had hatched. The most famous example of this is the remarkable Maiasaura, a name that beautifully translates to good mother lizard. Fossilized nesting grounds of Maiasaura reveal that these dinosaurs laid their eggs in organized, neat clusters and likely returned to the same communal nesting sites year after year. Even more incredibly, these nests have been found containing juveniles at different stages of growth, a clear sign that the parents were actively caring for their young, likely bringing food back to the nest for their growing babies. Some dinosaurs, like Protoceratops and Oviraptor, may have even nested in large colonies, working together to collectively protect their precious eggs from predators. Analysis of eggshells and fossilized embryos, such as those from Hypacrosaurus, show that some dinosaur hatchlings grew incredibly rapidly, a crucial survival strategy to quickly outgrow the danger of being eaten by predators. Of course, not all dinosaur interactions were so peaceful. What about the carnivores? The fossil record shows they displayed a wide range of sophisticated hunting strategies, from solitary ambushes to coordinated pack hunting. The great apex predators, like Tyrannosaurus rex, likely relied on ambush tactics, using their powerful jaws and an exceptional sense of smell to hunt down large herbivores like Triceratops. Fossilized bite marks and healed wounds on the bones of prey species give us direct evidence of these dramatic encounters. But what about the smaller predators? Could they take down prey much larger than themselves? The evidence suggests they could by working together. Fossil evidence from sites where smaller theropods, like Deinonychus, have been found in arrangements with their much larger prey, Tenontosaurus, strongly hints at cooperative, pack-hunting behavior. This strategy would have allowed smaller predators to take down animals they could never have defeated alone. Even so, many active hunters like T-Rex were likely opportunistic and would also scavenge carcasses when the chance arose, a dual strategy that would have increased their chances of survival. How did these creatures communicate? They likely used a combination of sounds, sights, and body language. Have you seen the strange hollow crest on the head of a Parasaurolophus? Scientists believe this may have functioned as a resonating chamber, allowing them to produce deep, low-frequency sounds to communicate with one another over long distances. And what about visual displays? The grand, bony frills of Triceratops or the striking crests of Dilophosaurus were likely used in elaborate courtship displays, or to assert dominance within their groups. We can only imagine the vibrant colors of the feathers found on many theropods, which could have been used for mating displays, much like modern peacocks do. And sometimes, fossils give us a direct snapshot of their interactions. The famous fighting dinosaurs fossil from Mongolia shows a velociraptor and a protoceratops locked in mortal combat, a moment of life and death struggle frozen in time for millions of years. From protective herds and caring parents to cooperative hunters and communicating rivals, the fossil record reveals a rich and complex social world, proving that dinosaurs were not simple brutes, but dynamic animals whose lives were just as intricate as the ancient environments they inhabited. Of course, we have journeyed through the dinosaurs' world and explored their complex social lives. But you might be asking a very important question. How do we know any of this? How can we possibly know the story of creatures who lived tens of millions of years ago? A story whose witnesses are long since turned to dust. The answer is a miracle of nature. It lies in the fossils they left behind. Veritable stories, etched in stone, patiently waiting for us to learn how to read them. This is the story of how we uncovered their world. Dinosaur fossils provide a remarkable window into the ancient past, offering us precious clues about the lives of these fascinating creatures and the environments they inhabited. From skeletal remains and fossilized footprints to delicate eggs and even impressions of feathers, each new discovery reveals incredible new details about the biology, behavior, and evolution of the dinosaurs. Over the centuries, the study of these remains, the science of paleontology, has itself evolved into a sophisticated field, using cutting-edge technology to uncover the deepest secrets of the prehistoric world. For most of human history, these strange, giant bones were objects of myth and legend, often mistaken for the remains of dragons or giants. But in the early 19th century, scientists began to look at them with new, curious eyes. Our story of discovery begins in 1824, when the British paleontologist William Buckland described a fossilized jawbone from a great carnivorous reptile, which he named Megalosaurus. This was the very first dinosaur species to be scientifically named and identified. Just a year later, in 1825, another pioneer named Gideon Mantell identified Iguanodon from fossilized teeth found in England. the discovery of this gentle herbivore was a major revelation, as it challenged the popular idea that all prehistoric reptiles were fearsome predators. It was in 1842 that the brilliant scientist Sir Richard Owen finally gave this astonishing new group of ancient reptiles a name: dinosaur, a term meaning terrible lizard. He recognized that their distinct characteristics, such as their upright limbs that held their bodies high off the ground, set them apart from any modern reptile. This new science sparked a fire of curiosity that soon exploded into one of the most intense rivalries in scientific history. In the late 19th century, two ambitious American paleontologists, Othniel Charles Marsh and Edward Drinker Cope, engaged in a fierce competition that came to be known as the Bone Wars. Their bitter rivalry was a mad dash across the American West to discover and name as many new species as possible. This period, though fraught with conflict, was incredibly fruitful, leading to the discovery of over 130 new dinosaur species, including many of the icons we know and love today. And where do we find these incredible stories in stone? There are special places around the globe, fossil-rich sites where the conditions were perfect for preserving the remains of ancient life. In North America, the famous Hell Creek Formation is a treasure trove of fossils from the very end of the late Cretaceous period, giving us skeletons of Tyrannosaurus rex, Triceratops, and Edmontosaurus, and even providing evidence of the asteroid impact that wiped them out. Far across the world, in the Gobi Desert of Mongolia, paleontologists have unearthed some of the most remarkable fossils imaginable, including entire nests full of dinosaur eggs, and the famous fighting dinosaurs fossil, an incredible snapshot of a velociraptor locked in mortal combat with a protoceratops. Dinosaur Provincial Park in Canada provides a stunning look at a diverse late Cretaceous ecosystem, while recent discoveries on the Isle of Skye in Scotland have revealed beautifully preserved Jurassic trackways. And in Argentina and Patagonia, scientists have found the remains of some of the largest dinosaurs to have ever lived. But what can a simple bone or a footprint truly teach us? A surprising amount. A complete skeleton reveals a dinosaur's size, shape, and structure, allowing scientists to reconstruct its physical form and understand how it moved. Their teeth are a direct window into their diets. The sharp, serrated teeth of theropods were for tearing flesh, while the grinding surfaces of hadrosaurs were for chewing tough plants. Even more amazing are the trace fossils. Fossilized trackways show how these animals moved, their gait, and even their speed. Some trackways reveal clear evidence of herding behavior or even predator-prey interactions. Fossilized eggs and entire nesting sites have revealed the incredible secret of their reproductive lives and parental care, such as how Maiasaura tended to its young. And in the rarest and most precious of fossils, we find impressions of skin and even feathers, like those found on Microraptor, which provide the definitive, beautiful evidence of their evolutionary link to modern birds. Today, the science of paleontology has advanced in ways the early pioneers could only have dreamed of. With modern technology, we can unlock secrets that were once thought lost forever. CT scans allow scientists to peer inside a fossilized skull without ever damaging it, revealing the size of a dinosaur's brain and shedding light on its intelligence and sensory abilities. By analyzing chemical isotopes in their fossilized bones and teeth, we can infer what they ate, the habitats they lived in, and even their migration patterns. With powerful computers, we can create digital 3D models of their skeletons to test hypotheses about how they moved, how a sauropod could support its massive neck, or how a T-Rex delivered its bone-crushing bite. The story of the dinosaurs is still being written. New fossils are discovered every single year, with teams of scientists from around the world collaborating to piece together the great puzzle of Earth's ancient history. Fossils are so much more than ancient bones. They are stories etched in stone, waiting patiently for us to uncover them and read their incredible tale. Every great story has an ending, and the epic tale of the dinosaurs is no exception. For 160 million years, they were the undisputed masters of our world, thriving in an incredible diversity of forms. But their long and prosperous reign was brought to a sudden, violent, and catastrophic end. This is the story of the day the world changed forever, one of the most significant and dramatic events in the entire history of our planet. The extinction of the dinosaurs was a global cataclysm that marked the end of the Mesozoic era. This mass extinction event, which occurred approximately 66 million years ago, wiped out around 75% of all species on Earth, including, tragically, all of the non-avian dinosaurs. So what could possibly cause such a worldwide disaster? The event that marks the boundary between the Cretaceous and Paleogene periods was triggered by what you might call a perfect storm of catastrophic events, a combination of terrestrial turmoil and a devastating blow from outer space. The beginning of the end came from the sky. Approximately 66 million years ago, a massive asteroid, roughly 6 miles wide, came hurtling through space and slammed into the Earth near modern-day Mexico's Yucatan Peninsula. The impact released an almost unimaginable amount of energy, equivalent to billions of atomic bombs, and it carved out a massive crater over 112 miles wide, known today as the Chicxulub crater. The immediate effects were apocalyptic. The impact sent out massive shockwaves, ignited colossal wildfires that may have ravaged vast areas of forest and created devastating tsunamis hundreds of feet high that swept across the ancient oceans. How can we be so sure this happened? One of the strongest pieces of evidence is a thin, worldwide layer of clay, rich in a rare element called iridium, which is found in rocks dated to this exact time. Iridium is uncommon on Earth's surface, but is abundant in asteroids, providing a clear chemical fingerprint of an extraterrestrial impact. But, as if this weren't enough, the Earth itself seemed to be turning against its children. Around the same time, on the other side of the planet in what is now India, massive and prolonged volcanic eruptions were taking place on a scale we can barely comprehend. These eruptions, known as the Deccan Traps, spewed vast amounts of lava, ash, and gases, like carbon dioxide and sulfur dioxide, into the atmosphere. This relentless volcanic activity contributed to a wildly unstable global climate, causing both long-term warming and acid rain, adding to the environmental stress. The combination of the asteroid impact and this volcanic activity created a cascade of catastrophic environmental changes. The deadliest effect was what came next. A thick cloud of dust, debris, and aerosols from the impact was ejected into the atmosphere, wrapping the entire planet in a dark shroud that blocked out the sun, potentially for months or even years. This plunged the world into a dark, freezing, nuclear winter effect that drastically cooled the planet. Without sunlight, photosynthesis on land and in the oceans ground to a halt, leading to a catastrophic collapse of the planet's food chains. Sulfur released into the atmosphere also combined with water vapor to create corrosive acid rain, which would have harmed vegetation and freshwater ecosystems. But why were the non-avian dinosaurs so particularly vulnerable to this new, harsh world? Several factors contributed to their demise. Many of them were enormous creatures that required huge amounts of food every single day to survive. When the plants died, the herbivores starved, and when the herbivores vanished, the carnivores soon followed. They also likely had slow reproductive cycles compared to smaller animals, making it incredibly difficult for their populations to recover from such a sudden and devastating blow. Furthermore, many dinosaurs had evolved to fit very specific ecological roles, and when those specialized ecosystems collapsed so suddenly, they simply lacked the flexibility to adapt to the new, hostile conditions. Yet, even in the face of such utter devastation, life, as it always does, found a way. Some species managed to survive the extinction event and live on in the world that followed. Who were these great survivors? The ancestors of modern birds, those small, feathered theropod dinosaurs, were one of the groups that made it through. Their small size, their ability to fly, and their diverse diets likely gave them the critical edge they needed to find food and shelter in the devastated world. And what about the mammals? Our own distant ancestors, who at that time were mostly small, often burrowing or omnivorous creatures, were better able to endure the harsh conditions. Their ability to shelter underground and eat a wide variety of foods gave them a crucial survival advantage. Other hardy creatures like crocodilians, turtles, and various amphibians also survived, as they were less dependent on stable climates and could endure long periods of scarcity. The extinction of the dinosaurs marked the end of an incredible chapter in Earth's history, but it also set the stage for a new one: the age of mammals. With the great dinosaurs gone, countless ecological niches were left open, and into this empty world, the mammals emerged. In the following period, the Paleogene, mammals diversified rapidly, evolving into a wide range of new forms, including the first primates, ungulates, and large carnivores. Birds also flourished, becoming the dominant flying vertebrates in the absence of the pterosaurs. The story of the dinosaurs' extinction is a stark and powerful reminder of the fragility of life, and of how sudden, catastrophic events can completely reshape the destiny of our planet. By studying this mass extinction, we gain a deeper appreciation for the interconnectedness of all life, and the powerful forces that have shaped our world's past, present, and future. Dinosaurs have captivated the human imagination for centuries, inspiring a sense of awe, curiosity, and boundless creativity. Their immense size, their incredible diversity, and their sudden, dramatic extinction make them a source of endless fascination for scientists, artists, and the public alike. They have become icons of ancient history, powerful symbols of Earth's dynamic past, and the enduring mysteries of evolution. However, our popular culture has also, over time, perpetuated a number of myths and misconceptions about these ancient creatures. As our scientific understanding has grown, advances in paleontology have corrected many of these misunderstandings, painting a more accurate and, in truth, a far more fascinating picture of what dinosaurs were really like. So, for our final exploration, let's debunk some of these common myths and celebrate the true enduring legacy of the dinosaurs. First, let's tackle a very old idea: the myth that all dinosaurs were slow, dumb, and sluggish creatures. For much of the 20th century, they were depicted as lumbering, cold-blooded reptiles with very limited intelligence. But is this picture accurate? The fossils tell a much different, more dynamic story. Fossilized trackways and skeletal structures show that many dinosaurs were incredibly active and agile animals. Predators like Velociraptor and Deinonychus had powerful legs built for sprinting and sharp claws for hunting or even climbing. The metabolisms of many smaller dinosaurs were likely quite fast, similar to modern birds, supporting the theory that at least some dinosaurs were warm-blooded. And what about their intelligence? While it certainly varied between species, some dinosaurs, like Troodon, had relatively large brains for their body size, indicating that they were capable of complex behaviors and were far from the mindless brutes they were once thought to be. Argentinosaurus and Tyrannosaurus rex were undeniably massive. Not all dinosaurs were giants. In fact, many dinosaurs were smaller than an average human. The tiny Compsognathus was only about the size of a chicken, while the feathered Microraptor weighed just a few pounds. This incredible diversity in scale was one of the keys to their success, allowing them to fit into a wide range of ecological niches. Perhaps the most persistent myth, thanks to cartoons and movies, is that dinosaurs and humans coexisted. Did cavemen really ride dinosaurs? The answer is an emphatic no. Dinosaurs went extinct approximately 66 million years ago, while modern humans, Homo sapiens, only appeared roughly 300,000 years ago. An almost unimaginable gap of tens of millions of years separates the two groups. While small nocturnal mammals did coexist with the dinosaurs, they were not primates or our human ancestors. For decades, we also imagined all dinosaurs with tough, scaly skin like a modern lizard. But one of the most exciting discoveries in modern paleontology has completely overturned this idea. Fossils of theropods like Caudipteryx and Microraptor reveal the unmistakable impressions of feathers. These were initially used for insulation or display, and only later adapted for flight in their avian descendants. This has led to modern reconstructions that depict many dinosaurs with vibrant feathers and diverse textures, making them appear far more bird-like and biologically plausible. And that leads to another point. While dinosaurs are part of the larger reptile group, they were distinct from modern reptiles. They shared many traits with birds, including hollow bones and nesting behaviors. And as we know, birds today are classified as avian dinosaurs, showing that the line is not as clear-cut as once thought. It's also important to remember that the other giant reptiles of the era, like the swimming ichthyosaurs and the flying pterosaurs, were not dinosaurs. They were different groups of reptiles that lived alongside them. Finally, let's address a famous movie myth: that the Tyrannosaurus rex had poor, movement-based vision. In reality, fossilized skulls show that T-Rex had forward-facing eyes, which gave it excellent binocular vision and depth perception, traits of a highly effective predator. Its vision was likely comparable to, or even better than, that of modern birds of prey like eagles. Because they went extinct, some have called the dinosaurs an evolutionary failure. But could anything be further from the truth? They thrived on this planet for over 160 million years, far longer than humans have existed. And in their direct descendants, the birds, their evolutionary lineage continues to thrive today, an unbroken chain of survival. This is the very definition of evolutionary success. So why, after all this time, do they continue to fascinate us? Their legacy is powerful. It begins with the sheer wonder of their size. Creatures like Argentinosaurus challenge our very understanding of what life is capable of. They offer us a profound glimpse into the vastness of deep time, a perspective that dwarfs our own brief history. They are a source of endless mystery and discovery, with each new fossil adding another piece to their grand puzzle. And perhaps most importantly, they offer us a direct, living connection to our planet's ancient past through their descendants, the birds. This incredible story has left a permanent mark on our culture, fueling our sense of wonder through books, films like Jurassic Park, and magnificent museums. Dinosaurs symbolize humanity's endless quest for knowledge and scientific exploration. They represent the extraordinary potential of life to evolve and adapt, and also the fragility of existence in the face of global change. And now, our long journey through the age of dinosaurs comes to its end. Let the images of giant sauropods and feathered hunters fade into the quiet of your mind. The ancient world is now at rest, and it is time for you to rest as well. Good night, and have sweet, prehistoric dreams.